in the sequence 1, 2, 4, 8, 16, 32, etc., each term after the first is twice the previous term. What is the sum of the 16th, 17th, and 18th terms in our sequence? So other than calculating what these terms are and summing them up, how can we find what these guys are? So let's sort of look for a pattern. So can we find sort of a generic equation or formula that will give us any term in our sequence? So we might notice that we have all powers of 2 here. So our second term in our sequence, for example, is equal to 2 to the first. And then our third term in our sequence is 2 to the second. So what about our first term here? So 1, well, how do you get 1 with an exponent? So raising anything to 0 gives you 1. So we could think of this as 2 to the 0th. So what does this mean? So it looks like any term in the sequence can be expressed as 2 to the n minus 1, where n is whatever term it is in the sequence. So in this case, the third term in the sequence would be 2 raised to the 3 minus 1, or 2 squared. So what does that mean? So the 16th term should be 2 to the 16 minus 1, which is 2 to the 15th. The 17th term should be 2 to the 16th, and the 18th term should be 2 to the 17th. So now, so they're asking for what is the sum of 2 to the 15th plus 2 to the 16th plus 2 to the 17th. So how can I do this without actually multiplying these all out? So what do these guys have in common? So each of my terms here shares 15 2's. So I should be able to factor out a 2 to the 15th and then just reverse engineer my exponent rule. So 2 to the 15th times 1 should get me back to 2 to the 15th, plus 2 to the 15th times 2 to the 1st should get me back to 2 to the 16th, because common base 15 plus 1 is 16, plus so then 2 to the 15th times what? Times 2 squared should get me back to 2 to the 17th, because 15 plus 2 is 17. So this sum here is just 2 to the 15th times 4 plus 2, which is 6, plus 1, which is 7. So 7 times 2 to the 15th, which is E.